Up until now, every time you use trigonometry to figure out things about a triangle, the triangle had to be a right triangle. So we have never talked about how to deal with triangles that are not a right triangle. And in the case of a right triangle, we just use SOHCAHTOA in order to use trigonometry and figure out things about the triangle, whether it be another side or an angle. We just used this. But this does not apply to triangles that are not right triangles. So now is the first time we're going to tackle triangles that are not right triangles. A triangle that is not a right triangle is called an oblique triangle. Okay, so it's just a triangle that is not a right triangle. And sometimes you will hear the expression solve the triangle or solving a triangle, and that just means that you're going to find all three angles and all three sides about the triangle, all three sides of the triangle. So basically figure out everything, figure out all the angles and all the sides. The law of sines is going to help us tackle triangles that are not right triangles, and it helps us in three situations. There are actually 5 possible oblique triangle situations. The law of sines is gonna tackle 3 of them. The other 2 are gonna be solved using the law of cosines, which is another lesson. So we concentrate this then on these 3. So these 3 situations are called the the ASA, the AAS, or the SSA. A stands for angle and S stands for side. So that would be then angle, side, angle, 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 side, and side, side, angle. The first one, angle, side, angle, means that you know 2 angles and the side that is in between them, or the side that is included, the common side. So for example, in this picture, suppose that we know these 2 angles, the ones that are clearly marked, that means that we know them. So we know these 2 angles and the side that is included, the common side. So you have this angle and that angle. So you see they share this side. So ASA means that you know these 2 angles and the side in between them. So this is one of the situations that the law of sines will be able to help. The other situation is the angle side. That's when you know 2 angles and a side that is not the side in between them, that is not the common side. So for example, in this picture, I know these 2 angles and I know a side that is not the side in between them. So it could be this one or it could be that one. In this picture, this one is marked, but it could have been this one. And lastly, the SSA is the situation where you have side angle. You know 2 sides and an angle that is not the angle in between them. So you know 2 sides, the angle in between them will be this one, so not that one. You want either of the other 2. So you know 2 sides and an angle that is not the one in between. So that's an example. It could have been this one. Okay. So those are the 3 situations in which the law of sines is going to help us figure out the rest of the angles or the sides. There's 2 more situations, and that's for the law of cosines. The other 2 situations are SAS, side angle side, so when you know 2 sides and the angle between them, or when you know all 3 sides. Okay, that's for the law of cosines. Alright, so here's the main, for these 3 sides that are solved by the law of sines, here's the main theme amongst all 3 cases. The main theme is this. You know at least one angle and its opposite side. So you know at least one angle and its opposite side. So you know a pair of an angle and its opposite side. So in this picture, you see you have this one and the opposite side. And in this one, even though you know these two angles and you don't know any of the opposite sides, however, this angle can be figured out really quickly because if you know two angles, this one is just one step, 180 minus that. Okay, so even though technically it's not given to you at the very beginning, you can figure it out in like 5 seconds. So in a sense, it's like you pretty much know it. So once you figure that out, then you would be in the situation that I'm talking about, which is you know one angle and the opposite side. Okay, so one angle, opposite side, one angle, opposite side, one angle, opposite side. So you always have to know one angle and its opposite side. If you have that situation where you know one angle and its opposite side, that's how you know you're going to be using the love signs. Alright, so what does the love signs say? Here's what the love signs say. First of all, let's go quickly over what is the standard way of labeling a triangle. There's a standard way, and you have to know this. So if you have any triangle, you can label the vertices any way you want. Usually we use capital A, capital B, capital C. So those are the angles, angle A, angle B, angle C. Or sometimes some books, some people use Greek letters. For Greek letters, it would be the first 3 letters of the Greek alphabet, alpha, beta, and gamma. Alpha goes with A, beta goes with B, and gamma corresponds to C. So you could either use capital A, capital B, capital C, or alpha, beta, gamma. Okay, but once you choose the vertices, the sides, you cannot choose them arbitrarily. The sides has to be exactly the same letter, but, the opposite side. Exactly the same letter, but the lowercase version. So, the side that is opposite to angle A has to be called little a, okay, small a, lowercase a. Like this is it. You cannot just put the a here or there. Has to be the has to be paired up with capital A. Similarly, the side opposite to angle B or beta has to be called little b, and the side opposite to angle C or gamma has to be called little c. So they are paired up like this. So capital A goes with A, little a, or lowercase a, or if you're using gamma, that would be these are the angles, these are the sides. Okay, and beta, or capital B, is paired up with little b, and then gamma, oops, sorry, this should have been alpha, my bad, alpha. Alpha in capital A, beta in capital B, and gamma in capital C, that would be lowercase c. Okay, so this is a pairing. That's a pairing. That's a rule. Alright, once you understand how a triangle is labeled, now we can talk about the love signs. The love sign says that if you consider those pairings, if you divide any side by the sine of the opposite angle, that proportion right there is the same throughout the entire triangle. So that means if you take any pair of a side and the sine of its opposite angle, that proportion, C divided by the sine of capital C or gamma, is the same as B divided by sine of B or sine of beta, and that's the same as A divided by sine of alpha or sine of capital A. So that division, that quotient or proportion, is the same for any pair that you take. That's the law of signs. You don't have to memorize this formula, but actually it's very easy to remember if you want to. Okay, here's an interesting fact before we do the very first example. That proportion right there, that number, that is the same for all three proportions, that number is actually the length of the so-called the diameter of the circumcircle. So every triangle can be inscribed inside a circle. So you can draw a circle, a so-called circumcircle. So it is the smallest triangle that contains is the smallest circle that contains a triangle, touches all the vertices. The diameter of that circle is this number right here. That's an interesting fact. It's true. We're not going to be needing it, but it's true. Okay, so let's do the first example. It says solve for the remaining sides and angle of the triangle shown below. Okay, so there's two ways in which they could give you this type of problem. They could give you a picture just like this, or the other way they could give you this problem is by telling you the values of the letters. So alpha is the same as A. This angle, because it is opposite to little c, this angle has to be capital C. There's no choice, but has to be capital C. Or gamma if you're using Greek letters. And then because I already used A and C, this one should be B, and it is beta, should be capital B. And the side opposite to capital B has to be lowercase b. There's like no choice for that. That's it. So one way they could give you this problem is by telling you, not giving you a picture, but telling you, angle A measures 98 degrees, little b equals 22, and then capital C, angle C equals 43 degrees. So this is another way in which they could give you the problem without a picture. Okay, and our job is going to be to find the rest. We have to find capital B, we have to find little a, and we have to find little c. Okay, that's what we have to figure out. Alright, so as I said, we're supposed to know an angle and its opposite side. We have to know a pair. Let's see if we, looking at this picture, if we know any pair. So lowercase a and 98. Well, I know 98, but I don't know that one. I don't know that angle, and I don't know that, and I know that side, but you see, I don't know that angle. I know this angle, but I don't know that side. So it seems like we don't know any pair, but we have to, otherwise we can use the law of sines. Turns out that though that angle is really easy to find. So that means this is the first case I told you about. This is ASA. In this case, you know two angles, you can figure out the third angle real quick. So let's do that. So what is B? Well, if I know these two angles, B is going to be 180 minus 98 minus 43, which is, what's that? Let's put in the calculator. So this is 180 minus 98 minus 43, 39. Okay, so B is 39. So that means we already found this one. Now we have to find the other two. So now this is 39. And now we know one pair of an angle and its opposite side. And that's going to be the proportion that we're going to use to compare the other two and figure out the rest of the variables. So that means we start with 22 divided by sine of 39. And then we can compare this to any other pair. So let's say I can compare it to this pair. That would be A divided by sine of 98. So A divided by sine of the opposite angle. And from here, we can figure out what A is. Multiplying by sine of 98 on both sides, or cross multiplying and dividing, we're going to get that A equals, so just solve for A, 22 sine of 98, all that over sine of 39. Now, let's put this in the calculator and figure out what A needs to be. 22 times, okay, my calculator is in radians, beware, we need to change that. Change it to degrees. Okay, 22 times um, sine of 98 divided by sine of 39. This is 34.61813382. Okay, notice that I copied all the numbers, and you need to do this. You are not going to round until you are done with the entire problem. I'm not done with the entire problem because I still have to find little c. So I'm not done. So until you're actually done with the entire problem, you should not be rounding. Copy at least 5 or 6 decimals. I copy all of them, but you should at least copy at least 5 or 6 decimals. Once we're done with the problem, then we round to whatever number of decimals they tell us, but not before. Okay, so now we have little a, and we still have to find little c, but just repeat the process one more time. Use the same pair as your comparison. So we're going to compare this ratio to, now replace, I'm looking for little c, so now it's going to be little c over sine of capital C, which is 43 degrees. So the side and the sine of its opposite angle. Do the same, cross multiply and divide. You're going to get that C equals 22 sine of 43 degrees over sine of 39. Now we'll put in the calculator and see what we get. 22 times sine of 43 divided by sine of 39. This is 23.84153467. Okay, and we're done. Now when we're about to enter this in the online homework system, now is the time where you would round, because now we are actually done with the problem. So if they say round to 2 decimals, then it would be 23.84 here, it would be 34.62 here, and then we didn't really have to round for the angle, capital B. And that's it. That's the law of sines. So always pair one side with the sine of its opposite angle. That's basically it. Just find a pair that you know and compare the other pairs to get equations that will help you figure out what is missing. That's it. So let's do one more example here. It says, solve the triangle shown below. Okay. In this case, we have a picture, but they could give us a problem without a picture. In this case, this would be capital A, this is capital C, beta goes with capital B, and they might give you the problem like this. A is 50 degrees, gamma equals, or capital C equals 30 degrees, And now, what side is this? It is opposite to capital A, so that has to be little a. So little a equals 10. So they might just give you the problem like this. Okay, and then ask you to figure out what is capital B, what is little b, and what is little c. Okay, your first job is to figure out whether you have a pair that is known, a side and its opposite angle. So I have right here, I have little a that I know it's 10, and the opposite angle that I know it's 50. So there you go. We have one pair that we know right off the gate. So that proportion between those two is going to be the standard that we're going to use to compare all the other proportions. So 10 divided by the sine of 50 is going to get compared with other proportions. So let's see. I can compare that with little b over sine of capital B. Well, I don't know what is capital B, but I should know at least one of these two. And capital B, even though I don't know it, I can figure it out really quickly because we have two angles and we can figure that out real quickly. So what is capital B? So that would be 180 minus 50 minus 30. So what is that? This is 100. Okay, so capital B is 100. So this means, going back here, this is sine of 50 degrees equals little b over sine of 100. Okay, now cross multiply and divide. You're going to get b equals 10 sine of 100 over sine of 50. And that gives us that b equals, let's put in the calculator, 10 times sine of 100 divided by sine of 50. This is 12.855752198. Okay, remember to copy all the decimals and only round when you're actually done with the problem. Okay, now take the same proportion and compare it to the last pair, which is little c over sine of 30. Okay, that gives me what? That gives us a c equals 10 sine of 30 degrees over sine of 50. Okay, let's put in the calculator. 10 times sine of 30 degrees. 30, okay. Divided by sine of 50. So this is 6.5270364447. That's little c, or lowercase c. Okay, if they told us round to 3 decimals, this would be 6.527, and that would be 12.856. And then there's no rounding needed for 100. I just want to make one more comment. It could happen that when you're trying to solve one of these problems using the law of sines, you could end up with an equation where you have two proportions equal to each other. So I'm just going to make something up. And you're looking for the angle. The angle is your unknown. So I just want to remind you how you solve this, because this could happen. So in this case, to get the c, well, you just cross multiply as before and then divide. So first cross multiplying, you get this. 5 times that equals 7 times that. And then you divide by 5. Okay, so that gives you sine of c. Now, what I really want to remind you is, how do you get c from here? How do you get c? Well, c is inside sine, and you need to get it out of there. So that means you need to find a way of canceling the sign, but the way to cancel the sign is to hit this equation on both sides with sine inverse. Okay, you don't divide, you hit it with sine inverse. So that means c would be sine inverse of 7 of sine of 20, all that over 5. And if you enter this in the calculator, you would get what c is. So let's do that real quick. So sine inverse of 7 times sine of 20 divided by 5. And that gives us that, if we round to one decimal, c, capital C, would be 28.6 degrees. Okay? So I just wanted to remind you that if you're looking for an angle that is inside a trigonometric function, then to find the angle, you have to hit it with the inverse function of that trigonometric function.